the M sub P is equal to this is computed earlier, no? This is equal to the yield strength Fy times Z sub X or the plastic section modulus. Kaya ganina, if you remember this one, M sub P is equal to this one, which is equal to 5,750 inch kilopounds, no? So, muna siyang 5,770 minus 5,750, 5,750 minus 0.7 times the yield strength Fy times the elastic section modulus, which is equal to, from the table, 103, no? Times the given value for the unbraced length L sub B minus the computed value for the L sub B over L sub R minus L sub B, no? You will get 4,572 inch kilopounds. To convert to feet kilopounds, divide this one by 12, no? So the answer is 381 feet kilopounds, which is true because this is less than the plastic moment, equal to 479.2 feet kilopounds. This 479.2, this is from 5,750 divided by 12, no? And this is your nominal moment, no, for the inelastic region. And to solve for the design strength, no, using LRFD solution, just multiply this one by 0.9 as your resistance factor. So the answer is 343 feet kilopounds. And for the ASD solution, multiply by 0.6 or divide this one by the factor of safety equal to 1.67, no? So this is your answers, no, for the LRFD and ASD solution. And for letter C, given the embrace length equal to 30 feet and the C sub B factor equal to 1.0, no? And yes, L sub R is already computed, no, equal to 29.28 feet. And the given L sub B is 30 feet, which is greater than L sub R, meaning the elastic lateral torsion backplane controls, no? So naa siya dito sa region sa elastic. So very long kaayo imong unbraced length, greater than siya than the limiting length, no? I-compute ninyo as 29.28 feet. So meaning the elastic lateral torsion formulas, no, will govern, no? So kani siya, ang pasabot ani is napa siya sa elastic, meaning imuhang section wala pa siya kaabot sa yield stress, ni bakol na siya, you know, sa tungod sa iyang kataas and brace length, wala pa ni yield ang steel section, unstable na ang length or ang imuhang member. So remember, to get the value of your nominal moment, you have to use the F sub CR. This F sub CR, this is the critical buckling stress, which is equal to this formula, no? C sub B, pi squared E over L sub B, R sub T, S squared, square root of 1 plus 0.078, JC over S sub X H sub O times the quantity L sub B over RTS squared, no? This one, C sub B is given, pi squared E, elastic, modulus elasticity of steel is 29,000 KSI over the unbraced length. This is converted to inches. So 30 times 12 over the R sub TS. This is computed already, no? Earlier, ganina. Equal to, or from the table, this is equal to 2.8, but we're using the answer from the computation equal to 2.799 squared. Square root of plus 1 plus 0.078 times j, this is also given from the table, no? Times c, which is 1.0 over s sub x, this is the elastic section modulus, 103 times h sub 0, this is also computed earlier, times 30 times 12 over the r sub ts, 2.799 squared. So the value of your critical buckling stress is 33.90 KSI. This one is used to compute for the nominal moment, no? Since this is in the elastic region, so you have to use the this critical buckling stress times the elastic section modulus. This S sub x is found in the table of properties also. So 30.9 times 103 muna siya answer, or divided by 12 to convert to feet. So 291 feet kilopounds, which is obviously less than the plastic moment, no? So gikan aning nominal moment 291 for the LRFD solution times the resistance factor 0.9, so the answer is 262 feet kilopounds. And for ASD solution, just multiply this one by 0.6 or divide the nominal moment by 1.67, so that the answer is 175 feet kilopounds. This is for letter C.